So today we're going to be talking about how to solve quadratics using a alternative method called complete the square. Um, Before we complete the square, let's explore how to solve a question such as this by finding the square root. And we'll see how this connects to completing the square. So when um, given a trinomial and equals a number that's not equal to 0, there is a way in some special cases like this where we can solve for x. Now this isn't just any trinomial, this is a perfect square trinomial. The reason I know that is, well, first off, it's a trinomial, and the first term is a perfect square. The last term is a perfect square, 10 times 10, and then the middle term is 2 times the square root of the first term times the square root of the last term. So 2 times x times 10, or 20x. So therefore, I can rewrite this as a factor, or a couple of factors, which is going to be x plus 10 squared, or x plus 10 times x plus 10. But I'm going to write it like this for this reason. So the idea here is I want to solve for x. So I want to get x by itself. So the way I do that is I need to get rid of the squared and the 10. Well, the first thing I want to do is get rid of the squared. So I do that by taking the square root to both sides. Now remember, since this is an even number exponent, this is going to be plus or minus the square root of 81. So I'll be left with x plus 10 equals plus or minus 9. Now all I have to do is subtract 10 from either side, which will leave me with x equals negative 10 plus or minus 9. Okay, because I have negative 10 and I can add 9 or subtract 9. So therefore, x is equal to, so negative 10 plus 9 is going to give me negative 1, or negative 10 minus 9 is negative 19. And those would be my two solutions for x. Now, let's talk about what completing the square is, or what that looks like, and then we'll relate it to what we're doing here. So I've set up some algebra tiles here. If you're not familiar with algebra tiles, there are three main tiles we work with. Here's in the bottom right corner here, I have a 1 tile, and we say it has dimensions of 1 by 1. So 1 by 1, so it has an area of 1. I have an x tile here, which has the dimensions of 1 by x, so it has an area of x. And then the x squared has the dimensions of x by x, so it has an area of x squared. So that's how you read algebra tile. Now, I have a, we're going to ignore the 1 in the bottom right hand corner right now. We're just going to look at what I have right here. And I have an expression here, and I have a single x squared, and I have a total of 6 x's. So my expression here is x squared plus 6x. Now what I want to do is I want to do a thing called complete the square. And basically I want to make a square using these tiles here. So the way that I would do that is I'm going to take these x tiles here and I'm going to split them in two. So I'm going to take these three tiles, I'm going to split them in two, and I'm going to take them and I'm going to put them on their side like so. And then I'm going to line them up underneath the x squared, like this. Okay, so now what I need to do in order to complete the square is I got to fill in this gap, and then I'll have a square. So I can't, I can put this one tile here, and it's not enough, so I need to fill up this whole thing with one tiles. It looks like I'm going to need a total of 9. So let's see, 3, 4, 5, 6, 7, 8, 9. And I'll just go ahead and put them in here. There we go. That's 6, 7, 8, and 9. And that makes our square. More or less, not perfectly aligned, but you get the idea. So we've completed the square. Now, what does this mean? Well, before, when I had these laid out, I had x squared plus 6x. Now, if I look at what I have down on the sides here, on this side, I have an x. Okay, I'm just looking at the edge here, an x plus 3, and on this edge here I have an x plus 3. So I'm just looking at the edges, not looking at the x squared plus 3x. It's just saying, oh, this has a length of x, and this has a length of 1, 2, 3. Remember, these sides are 1s. 1, 2, 3, and this has a side of x. So giving me the x plus 3. And then here, if I look, oh, this has an edge of x, and here plus 1, 2, 3, and on this side here, x plus 3. So I can tell that this is, in fact, a perfect square. So I started my equation off with x squared plus 6x. So what did I still have the x squared and 6x's, so I asked myself, well, what did I add to this in order to complete the square? And I'd answer, oh, well, I had to add 9 ones total. So I'm going to say plus 9. So to complete the square, I have x squared plus 6x plus 9. And I can do this with a variety of terms. So if I wanted to, I could take something, for instance, like x plus 4x, and I want to figure out what the value of c is. And the idea here is I would take that 4x, those 4x's, and I'd break it into 2x's. And then I would actually square that. So I would say, oh, well, this is going to be x squared plus 4x. So 4 divided by 2 squared is going to give me 4. Just like I would do here. I broke these in two, and if I looked at the remaining space here, so this is 3x, and this is, I'm sorry, not 3x, but 3 rather. And this space here is 3. So I took the 6, I divided by 2, which gave me 3, and then to fill up this space, I had to square 3. So 3 squared is equal to 9. If I do, let's try one more. So let's say I had x squared plus 8x, and I want to figure out, well, what does c have to be in order to complete this square? So 8 divided by 2 is 4, and if I square 4, that's going to give me 16. So plus 16, and that completes the square. And I know I complete the square because I am left with a perfect square trinomial. So for instance, this equals x plus 2 squared, and this one equals x plus 8. x plus 4 rather, squared. X plus 4 squared. So the algorithm for completing the square is c is equal to the b term divided by 2, and then we square that. So let's look at an example of a problem that you might encounter. So I want to find the value of c that makes x squared minus 26x plus c a perfect square trinomial. Then we're going to write that as a square of a trinomial. So I would start off, and I would look at my b term here, which is 26. I'm ignoring the sign right now. We'll talk about what the sign does in just a moment. So my value of c is equal to, so we take that 26 term and we're going to divide it by 2. So that's that b divided by 2, and then we're going to square it. So in other words, we're going to take 26, divide that by 2, and we'll square it. So 26 divided by 2 is going to give us 13, and we square that, and that's going to give us 169. So our perfect our c value is equal to 169. Okay, so it would take 169 of those little yellow algebra tiles to complete the square, and so our equation would be x squared minus 26x plus 169. Okay, now it says write the expression as a square of a trinomial. Actually, it should be binomial of a binomial. And to do that, well, I'm just saying, well, what kind of binomial would give us this? What square binomial would do this? Well, this is x is a perfect square. That's x times x. 169 is a perfect square. 13 squared. And if you double 13, that's going to give you 26. The minus sign in front of the 26 tells us it's going to be x minus 13 as opposed to plus. That's going to be a minus 13 squared. And so that is going to be the square of our squared binomial. All right, so now let's take this and we're going to combine it with that first example, and we're going to solve. Now this is so completing the square isn't a method we could use to solve certain types of trinomials. So here's one. I have a trinomial. There's nothing special about it. In that, I mean, it's not a perfect square. I mean, this is a perfect square. The c is a perfect square. The middle term is not 2 times a times c, because the square root of 1 is 1, but 2 times 1 is 10. And so that's not going to work. What we can do is we can complete the square. And the first thing I want to do is I want to set it up. So I'm going to subtract 1, because all I want is the a and b term. So the x squared and the minus 10x, and then equals negative 1. Now we'll complete the square. So I'll look at the 10 and divide that by 2, which is 5, and we square it, which is 25. So it's a real easy process. So plus 25 equals negative 1. And what we do to one side, we must do to the other. So that rule still stands. And I'm left with x squared minus 10x plus 25 equals 24. All right, since this is a perfect square trinomial on the left, then I can simply write this as x. Okay, so the signs are minus and plus, so that's going to be minus 5 squared equals 24. And now we solve for x. So I'm going to take the square root to both sides, here and here. This is going to be plus or minus leaving me with x minus 5 equals plus or minus the square root of 24. Now, I'm going to simplify that. 24 can be simplified to, let's see, perfect square that goes in there is 4. So, and the square root of 4 is equal to 2. So that would be 2 square root 6. And now I'm going to add 5 to both sides, here and here. So x is equal to 5 plus or minus 2 square root 6. So make sure your radical is simplified and then leave it like this. This is an accurate answer. Don't worry or bother putting this as a decimal. This would be the better way to present your answer. One thing I want to point out in this example is that, like all the other examples, we can solve this by completing the square. In this example, our b term is even, and we can complete the square with any b term that's even. But if it's odd, we can't do it. So if we got like a 5 or a 111, we can't divide that by 2 evenly. So that's one of the key things we have to be aware of when trying to solve something by completing the square. That'll be one of our limitations. So this one does have an even b, so we can do that. But before I do, I really should be looking for a greatest common factor first. Like any other trinomial we factor or solve, we should be looking for GCF first. And there is one. Now, instead of factoring out the GCF, we're going to just divide it out, because the GCF here is not going to help us find any values of x, since the GCF is just a constant. In this case, 3. So I'm going to divide it out. I'm going to divide out both sides by 3. So I divide this by 3, and I would divide this by 3. That would leave me with x squared minus 12x plus 50, and of course 0 divided by 3 is just 0. Now I'll set this up to be completed by the square, or complete the square if you will. And I'll ask myself, well, what is my value of c? So 12 divided by 2 is 6, and 6 squared is 36. So I'll have x squared minus 12x plus 36 is equal to negative 50. And of course, what we do to one side, we have to do to the other. So I add 36 to the left, I must add 36 to the right as well. So on the left side, I'll write this as a square of a binomial. In that case, it's going to be x minus 6 squared equals negative 14. Now I will take the square root of both sides, here and here. So this will be plus or minus. And I'm left with x minus 6 equals plus or minus. Well, since I'm taking the square root of a negative number, I'm going to have to write this as an imaginary number. So I square root 14. Finally, I'm just going to add 6 to both sides, and I'll be left with x equals 6 plus or minus I square root of 14. And that would be, or those would be my two solutions, which both happen to be imaginary. The next question here is where we're going to be converting from vertex form, or from standard form to vertex form. So we've already done vertex form to standard form, and in intercept form to vertex to standard form, but we haven't done standard form to vertex form. and which is the last one. We have done standard to intercept form where we just factor it. So this one is this involves the most. It's not a whole lot, but there's a little bit more to this. So what I want to do is I am going to set this up a little bit differently. I'm going to say y plus something is equal to, and then over here I'm going to have my x squared plus 18x, and this is going to be my parentheses, where I'm going to have, my square, and then I'm going to have plus 95 here at the end. This is where my k value is going to go. Recall the form of this is y equals ax minus h squared plus k. And right here we have x minus h squared, which is a square of a binomial. So what we want to do here is turn this into a perfect square trinomial, so then we could write it as a square of a binomial. So that's why we're going to complete the square. So I'm going to have plus something here, and then of course what I do to one side I have to do the other. That's why I have a plus something on the y. So I'm going to say, well, what's my c value going to be? So I'm going to take 18, divide that by 2, which is 9, and square it, which is going to give me 81. So I'm going to add 81 to both sides. So now I have y plus 81, and now I can write this as a squared binomial, or a square of a binomial, which is x plus 9 squared plus 95. And now I wrote 18 over here. Let's make that 81. That was a moment of dyslexia. I'm going to subtract 81 from both sides. And I have x plus 9 squared, and then I'm just going to subtract those, leaving me with plus 14. And that's going to be my k for value. So now it's in vertex form from standard form. So now we can convert between any of the forms back and forth. We have all those tools available to us. Let's do one application problem. In this example, we have the height, y, measured in feet, of a ball that was thrown up in the air, matches the function y equals negative 16t squared plus 64t plus 50, where t is time, measured in seconds. Find the maximum height of the ball. So we want to find the vertex of this. The negative 16 tells us that we'll have a parabola that's going to open down. So our vertex is going to be a maximum, and that's going to represent the maximum height of the ball. So we have to find the vertex. In order to find the vertex, we need to take this equation, this formula, that's in standard form, and convert it into vertex form. Once it's in vertex form, we can figure out the maximum height pretty easily. I'll start off by defining my variables. So I'm going to let y equal height of the ball, and I'm going to let t equal time, and this is measured in seconds. So I have y equals negative 16t squared plus 64t and plus 50. Before I start, I'm going to look at, well, I'm going to go ahead and group this, create my group here where I'm going to have to complete my square. But before I complete my square, I'm going to ask myself, well, is there any greatest common factors within this group? And my answer to that would be, well, yes, there is. There's going to be a negative 16. I always want this t squared term to be positive if possible. So I'm going to factor out a negative 16. So that's going to leave me with t squared plus 4t. Except that's going to be a minus t since we factored out a negative 16. So, like so. And then we'll have a plus 50. Now I need to complete the square, so I'm going to say y plus something is equal to negative 16 t squared minus 4t plus something, and then plus 50. I'm going to want to be, I want to be careful with this one because I'm going to start off and I'll complete the square just fine. I'll say, okay, well, 4 divided by 2 is 2 squared. It's going to give me 4. And then what you do to one side, you do to the other. But you don't write just plus 4. That would be a mistake because I'm not just adding 4 here because notice that we have a negative 16 here that would distribute with each thing in here. So it's actually negative 16 times 4, okay, because we'd multiply those together. So to compensate that, I'm going to say negative 16, so plus negative 16 times 4 on this side. So now we've actually done it to both, what we've done to one side, we've done to the other. So that's it. Now we just multiply negative 16 and 4 together, which would give us negative 64, which equals negative 16. Now we can write this as a binomial, x minus 2 squared plus 50. Last step here is to add 64 to both sides, and this will give us our equation y equals negative 16 x minus 2 squared plus 114. Now that it's in vertex form, I can easily identify my vertex, which is located at HK, so 2 and 114, but it's asking for the height. What's the maximum height? And my maximum height is y is equal to 114. So I would say, therefore, the highest point that the ball reaches, or the ball gets, is 114 feet in the air. And that's what I would box in. So that's how you can use completing the square to factor or solve trinomial equations or expressions. I'll see you on the flip side.